Luca, where are you?
Alright, entertaining now for you. Okay, so we need to go ahead and double check the calendar because remember how we were going to have that test after President's Day? It was going to be awful and awkward. Now we're not. It's Friday. Get out there. Okay.
Is it a week?
But look, we gotta focus today. We have to finish partial fractions. That homework is due on Monday. Then 7-5, 7-5, 7-5, 7-6, 7-6. There we go. Then review the test. So we have a couple things still coming. There's a random homework assignment that I don't know what happened. It should be on that day. I'll fix it. It disappeared somewhere. And here we are in 7-4. So some of you guys know what's going on. It's a good thing you guys have been working awesomely for Chapter 7 so that we don't have to take the test after President's Day. That would be so sad. And so your homework that weekend will be rest from pre-cal. Sound good? But we got to earn our right to get there. So here we go. Partial fractions. You remember? We start with a fraction that's been put together, kind of. And we have to break it apart. True? This is a quick summary version of, I'm taping, right? Yeah. This is a quick summary version of the steps, but we got to go ahead and flesh out the steps a little bit more today, work them out a little bit more. Did we finish yesterday? Oh, we were so close. All we had to do was solve the system. What do you guys think? Substitution or elimination? Oh my goodness, you're so scared of these. All right, substitution. So, we gotta solve for A, we gotta solve for B, because as soon as we can solve for A and B, wait, do you guys see where A and B first appeared? Where did it first appear? Here, right? When we formed our partial, if we find A and we find B, guess what we just solved for? Our partial fractions. Problem done. So, here we go. A and B, you guys said substitution. Who am I solving for? A or B? Alright. So A equals B minus 1, true? What am I going to do with that B minus 1? Plug it in to the other equation. So I'm going to end up with negative 3 times B minus 1 minus 2B equals 7, true? Oh, is it? Sorry, my little black thingy covered up the other thingy. Is it plus? Yes. Oh, it's a plus. Okay. Oh, see, I'll move my circle so I can see it better. Thanks for catching that, or else it'd be very sad. Yeah, please.
If you because you subtracted the A and that way and then subtracted the 1, but then if you multiplied by
I did do illegal stuff. Did you guys not catch me?
I just wanted to.
You guys are cute. You don't really answer yes, but you don't really answer no either. Okay. So what does A actually equal?
B plus
1 minus B.
1 minus B. I just did it backwards. You see it? I was solving for this guy by subtracting B for both sides. But silly me, I did it way too fast in my head. So I need to plug in, instead of B minus 1, who goes in there? Yeah. So now I have negative 3 times 1 minus B. All right, now I'm on track. Don't worry, no more mistakes. Just kidding. Who can actually promise that? Jesus. Okay, so. Isn't this just a simple distribute and solve, guys? Oh, okay. So I have negative 3 plus 3B plus 2B equals 7. Add the 3 to the other side, that's 10. Over there, that's 5. So I have 5B equals 10. B equals who? 2. You guys got the same thing? Mm-hmm. Don't I have an equation just waiting to be plugged into up here? Sweet. Let's go back and plug it in. And A is equal to 1 minus 2. You guys got negative 1?
Yes.
What do I do with those 2? Put them where they're supposed to go. Where are they supposed to go?
Them into your fraction.
Yep, my partial fractions. So my original x plus 7 over x squared minus x minus 6 came from, or could come from, negative 1 over x plus 2 plus 2 over x minus 3. Could you check this? Oh, yeah. How would you check it? Get a common denominator, and guess what's going to happen because we're amazing? It's going to match. And if it didn't match, there was just some sort of silly mistake you made, like the ones I just made, somewhere in your math. Question: did the steps work?
Yeah.
Why, yes, indeed they did. So let's go try them again. Sound good? We gotta get a system down. We can get a system down, then we can use it whenever we need to find partial fractions. Wait a minute, is this the same thing? Oh no, it's different. Okay. Ignore. Actually, no. You can write the thumb trick. That's okay. I'm going to introduce you to a trick for these simple ones. Simple ones. That wasn't simple. No, but it was foundational and it was basic to this topic. Not basic to math. That would be like 1 plus 1. However, basic to partial fractions. This is another basic example. Let's see if you guys can figure out why it's basic. Alright, step number 1, check to see if it's improper. Oh, yep, improper first. Does the top win or tie the bottom in degree? Does the top win or tie the bottom in degree? Nah, because the bottom's degree is 2 and the top's degree is 1, so forget that. Improper, don't care, it's not. Step 2, factor. Step 2, factor. You guys notice I am not writing the steps anymore because you don't need them. Just kidding. You do, but life's too short. Or at least our class grades are too short. Do my factors work? Yeah. Step 3, after factoring, make your what? Partial fractions. What kind of factors do we have if you guys look right here? Are these linear or quadratic? Linear. Now they could be cubic or quartic even. We don't deal with ones that hard. Okay, they're linear. Oh, and maybe linear are easier than quadratic? Oh, maybe that's why it's basic. Linear factors. No repeated linear factors. Wait, how do we put the numerators? Do we know what those numbers are? No, that's the whole point. We gotta find it. So what do we put there instead in the meantime? A and B sounds great. Unless you really want to do the subscript A sub 1, A sub 2, A sub 3.
Okay.
That's not.
Let's not.
Okay. Let's not say we didn't.
Okay.
Okay.
With the exactly. That's just the way she said it.
You're not supposed to lie. You just say we what's step number 4? Improper, we did that. Factor, we did that. Make our partial fractions, we did that. Step number 4 says multiply both sides by. Now you need to write this until you have the hang of it. Who is the common denominator? You guys see it?
Yeah.
What's going to happen on the left? Always, always, always? It's going to cancel because that's what had the common denominator. So on the left it cancels. Maybe I should say reduces. Now I am going to show the work, but hold on. Maybe just a few of you can start skipping a step and saying, hey, the A is going to be times x plus 1, and the B is going to be times x plus 3. Wait, what? I don't know. Huh? For those of you that can't see that. Yeah. For those of you that can't see that, remember the A over x plus 3 gets multiplied by both. And the B over x plus 1 gets multiplied by both as well. Has to distribute both pieces. Then I can say, hey, that reduces, right? Reduce, a math term. Does anybody know where else the term is used? math term, reduce. What else could it be used? Yeah, that's still math though, yeah. Let's see another category. You guys aren't in the kitchen much, huh? Thinking of reduction? Yeah? No, nothing? Anyway. You guys need to watch like Chopped or something. So, coming back. Listen, you'll hear reduction. It means reducing into, isn't it usually fruit?
Oh, like when I do
Like
fruit
when they do like a red wine and the,
Yeah.
He goes to wine. I said fruit. Okay.
It could be like a sauce.
So it's like a
What's
reduction.
wrong
So
with
they'll
you
boil
guys?
it. I don't know how to make it.
Anyway, shush. Rebels. Question. Just kidding. We end up with what we have. That makes sense. Now what do we do? Step number 5.
Distribute.
Oh, combine the like.
Solve. And one way to solve is to combine the like terms. Do you want me to show you another way besides, or should we do combine the like terms again? Okay, let's do another one. If you guys look, there's A, B, and C, right? A is combine the like terms and make a little system out of all the x terms and all the constant terms, right? B says use strategic x values to plug in. Strategic. Ready? Strategic. A strategic x value to plug in would be what's going on for or when x equals -1 and for or when x equals -3. Now, I just chose 2 very strategic x values. We're not going to talk about it. We're going to actually do it, and then you guys maybe can tell me why they were strategic. Good strategic as opposed to bad strategic. Let's see. Plugging in -1. -1 minus 2 on one side. A times -1 plus 1. Plus B times -1 plus 3. Skip a line. -3 minus 2 equals A times -3 plus 1 plus B times -3 plus 3. What happens to the -1 plus 1? The A is gone. What happens to the -3 plus 3 in the other one? And the B is gone.
Wow, that's so much easier.
Hey, maybe it is. Look at this strategy. We end up with -3 is equal to 2B. So what does B equal? That's pretty spiffy, and I didn't even have to use a system or have X terms or any of that.
Wait, but you have to use any number, right?
Well, it has to be strategic. We'll come back to that in a second. The next one, we end up with -5 equals, what does the coefficient of A become? -2A. See it? So what does A become? Careful, yeah, divide by 2. What? Now, can someone, I know quite a few of you saw it even before I started the math. Karina, why was my -1 and -3 strategic?
Because, like, if it's like you can set x plus 1 and x plus 3 equals 0, and you just use it.
Yeah, if there are zeros of the factors, I can use them as my strategic x values because when I plug in, that guy's going away. If I plug in -1, the term with x plus 1 is going away. If I plug in -3, the term with -3 is going away, and then this math becomes kind of quick and fast. How do you guys like the strategic values? Because now, aren't we done? Well, basically. What do we need to do?
Plug it in.
Plug it in, plug it in. I shall go ahead and show that. I'll keep that up. So we end up going back to the beginning and saying, who are those partial fractions that we're supposed to be finding? Oh yeah, these guys. And we just plug in. Now, do you guys see how solving a system for these might have been really gross?
Yeah.
Good thing we did it the faster way. So we end up with over x plus 3 plus over x plus 1. Now, why am I going to write it funny, though? And why am I going to put -3 over and 5 over. Yeah, I guess I could put negative 3 over 2 in the top and 5 over 2 in the other top. But then it's a nasty complex fraction, so I'm just kind of multiplying or bringing it in. Yeah, the top goes on top, bottom goes on bottom. I'm just bringing in the fraction and showing the numerator denominator component with the factors. Nicole?
How do you know like which way you're supposed to solve? If you're supposed to do like the plugging in.
Technically, once you see them all, sometimes only one of them works, sometimes all of them will work. So it's just kind of a personal choice assumption. But we will see some trickier examples where maybe the strategic values don't work quite so well. Or the system of equations is really messy, we wouldn't want to do it if we could avoid it. Luke?
What makes this called a function?
Say it one more time. Oh, because I'm about to show you how any simple partial fraction can actually be solved. We're using this example to help us show. Any basic partial fraction that has, what was in common in the last two examples? Their factors were linear. Any partial fraction, or I should say, any function that we're trying to do partial fractions with that only has linear and non-repeated linear factors can be solved with a thumb trick. And a thumb trick is basically a shortcut version of our shortcut. It's a shortcut version of the strategic values. So let me show you another way of solving this with the shortcut of the shortcut. Ready? Same exact example. Same exact example. If I was to steal, can you guys read this off to me in just a second? Let me get another page real fast. Do I still have it? Nope, I don't. Okay, what's the partial fraction or the function we're trying to reduce down?
X minus 2 over x squared plus 4x plus 3.
Okay, good. Which we figured out factored to be x plus 1 times x plus 3, right?
Yeah.
Alright, let's see if we can make this work. You guys saw how a second ago I plugged in -1 and plugged in -3, right? The cool thing is what we can do is we can actually, with the thumb trick, we can make our partial fractions, and with showing little to no math, we can fill in the numbers. What? Little to no math, we can fill in the numbers with the thumb trick, but only when, once again, we have linear factors that aren't repeated, aka they can't have any like powers or anything like that. And here's how you do it. You choose a factor. Choose one. Okay, choose this factor. Who is his 0? Okay, now you ignore this factor. And you plug in -1 everywhere else. What? Ultimately, you're doing the exact same math as the long process on the other page. Plugging in -1 to the top, don't you get -3?
Oh my gosh. Yeah.
Plugging in -1 to the bottom, don't you get 2?
Oh my goodness, it's so fun.
Now wait a minute, why did I put it in that spot and not the other spot? Who was I looking at? So I had to match it with the x plus 1 one. Now some of you are like, no, I really just did the math on the other page, but really, really, really fast. Why is it called the thumb trick? Look, pretend it wasn't on the screen. Can I cover one with a thumb and plug it in? I cover the factor with my thumb. Okay, not on the actual smartboard, on your paper. Only I was that cool. I'm not that cool. But look, I cover the x plus 1 with my thumb and I plug in -1. So what am I going to do for the x plus 3? Plug in -3 everywhere. You guys going to do it? I'm going to choose a different color. Cover the -3. You could cover it with your thumb and not have to like actually scribble it out and then erase it. I shouldn't have done it. Hold on, I have to do it bigger or else it's not going to be able to go away. Okay, plugging in -3. -3 minus 2. -3 plus 1.
This is so awesome.
Isn't that cool?
Yes. Wait, that's weird.
Negative over a negative, I know I lost my negative. A negative over a negative is a positive, so I end up with, ready? Negative 3 over 2 times x plus 1 plus 5 over 2 times x plus 3. How's it look compared to the other page? Same thing. Woo! Lot less math. But it does the exact same process, which is pretty cool. You guys want to do one on your own, see if you can find it fast? All right, here we go. Let me do one more. Yeah.
So when we first did it, it was like 5 and then -3. Does it matter the order, or does it?
Ooh, double check the denominators. I just happened to write them in a different order on the page before, see? But the correct numbers went with the correct factors. Oops, undo. This guy was the purple one with the x plus 1. This guy was the green one. So remember, addition is commutative. I just happened to do a different order of the factors. Does that make sense?
Yeah.
Cool. Good question, okay. Okay, here we go. What if I was to give you, you guys can play with this one, 2x minus 1 all over, I can't make it super easy. I'll make it kind of easy. Let's do x squared minus 5x plus 6. Ready, set, go. You can use the long drawn out math method, which is fun, with the system and or the strategic values, or you could try the thumb trick. I'm going to freeze the screen so you guys don't see my work, but then you'll be able to see my answer when I finish. Luca, sorry, you'll see my work. And Brandon. Almost ready for the unveiling. If you don't want to look yet, don't look yet. But if you're ready, how'd it go? Double check the math. Double check what you covered and how you covered. I'm going to pull apart the shading just so that you guys can see the original function. I had to factor. Make sure you factored right or else it would have been wrong. You guys saw my shading, right? When you plug into 2, you better not be plugging into him. And if you guys did try to plug into him, you kind of get over 0. It's bad news. So you ignore where the 2 is to get the -3 or the 3 over -1. And then when you plug into 3, you have to ignore the other factor. Plug in to get 5 over 1 in order to solve. Any quick questions on thumb trick? Yeah.
Does it matter if the -3 and 5 are switched?
It only matters if they're not with the same denominator. So you could have 5 over x minus 3 plus -3 over x minus 2, but you can't have them like mixed with the wrong denominator. Nicole.
How do you know if the side on the left is plus or minus?
It's always plus, but say the 5, now this isn't true, so let me make it some weird color like teal. Say this was a negative 5. You could have put the negative here, or you could have instead, you could have made it a minus. So the minus will only come when the number is a negative. Or you can always put an addition and then make the numerator negative instead. So the long story short of it is it's always a plus. It's always a plus. But sometimes the numbers will be negative in the numerator. Now, once again, sad but true. The thumb trick only works when you have, and it might be a good thing to put, when you have what types of denominators? With easy, non-repeated, I know it's sad, but the cool short trick works with the cool, easier ones. But that's all right. If we can make the easier ones easier, we have more time for the harder ones, right? All right. It's okay. You can groan for like half a second, meaning I shouldn't be able to hear it. And then keep going. With easy, comma, non-repeated, comma, I know so many restrictions, linear factors. It's okay, it's sad but true. It's time for us to go find harder ones. But we made the easier ones easier. Easiest, I don't know, it's up to you. But we made the easy ones easier. Let's go face some harder ones and see what to do with. What happens if we have repeated linear factors? It is right now, but we're going to make it nicer first because step number 1 says check to see if you have what type of fraction. And if we have improper, what are we supposed to do? Thought process. Is it improper? Yes. So divide. Do you have to write that? No, of course not. But you have to go through step 1 in your head and say, uh-oh, top wins. It's top heavy. It's going to be way too hard unless we cut them down to size. How do we do that? I'm not sure if I'm feeling factoring because if it was an easier one, it would be a good idea. If it was an easier one, it'd be a great idea. But yeah, no, let's just divide.
This is so gross. Right now.
Oh, kiddos, calm, 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 calm. We'll get through it as long as we work together. Emphasis on the work. Okay, so
Yes.
x cubed goes into x to the 4th. X times. True? Can I go quick? How am I getting that? Right? Okay, I'm distributing to everybody. Now, it's division, which means I need to, next step, subtract, right? Which means I have to change all the signs to opposite, true? Okay, x to the 4th minus x to the 4th, gone. 2x cubed minus 2x cubed, gone. Oh, he's not too bad. X squared minus, 6x squared minus 1x squared. All right. Keep dividing. Wait. Does he go into him anymore? No. What does that mean? 0? Well, that was a very long and complicated, very short division. We're done.
Wait, what?
Okay.
Oh, you're right.
We have just changed our problem to be the following. This whole nasty blah, blah, blah has now become x plus, take the remainder. Remember how we write remainders? Except our goal isn't necessarily to factor the top. Our goal is partial fractions, so let's just factor the bottom. Right? It's okay, you can be scared, but we just changed our problem to not be near as complicated. You guys see it? Do we have to reduce this guy to his partial fractions, or is he not even partial? He's a whole number. Well, he's a whole variable, right? So he's fine. Forget him. Who are we worried about right now? We're worried about this guy, right? So now we're going to take that guy and say, all right, it's time to find your partial fractions. How do we find his partial fractions? Well, we've already divided, so step number 2, we factor. True?
True.
All right. True, true. We have x. You guys see the repeated x, right? X squared plus 2x plus 1. This should look familiar. What's x squared plus 2x plus 1? Can we factor it further? Exactly. Now wait, eyes up here. Do you guys see what I did? I pulled out an x. Now why am I erasing this guy? Because I can factor more and say, oh, he's x plus 1 quantity squared. Or if you want, you could technically do x plus 1 times x plus 1. If that helps, you can do x plus 1 times x plus 1. That's not a pretty way of writing it, but it will work for now. After you factor, make partial fractions, right? Wait, why is this really so much harder? Well, there was long division, right? There was long division we had to do. But now, doesn't it just kind of look like no big deal? Put in x plus 1, and then put in x plus 1. Wait, there's...
You can't forget
There technically is still a big ol' x in front of the entire answer, but remember, we're only getting partial fractions for what part? Just that part. So right now we are zeroing in on only him, right? So we can't forget the x plus in the final answer, but for right now we're just looking at the other guy. Do you guys notice how the second two are the exact same thing? Well, that's confusing. Like, what do? Do we name it like A and B? Or, well, that's, why are there 2 of them? Should we name it C? But then would there be 2 different numbers on, that's confusing. Ready? Whenever you have repeated linear factors, what do I mean? There's more than 1. There's actually something very special we have to do, sadly. We have to make 1 to the first power, and we have to make 1 squared. Can anybody tell why? We have to make 1 for a single x plus 1 and 1 for both x plus 1s. Why? Could he get a common denominator to make him? Yeah. Could he get a common denominator to make him? Yeah. Could he get a common denominator to make him? Yeah. So we have to think of all the different possible options of someone who's not the entire denominator, but has pieces that could combine to be. Now this only has to happen when you have repeated factors. When you have repeated factors, you start with the lowest power, which is 1. And then you have to go up to the highest power, which will be the same as how many we have. We went up to 2 and we stopped. Okay? Now, here's where it gets a little bit tricky too. This guy's going to have an A, right? This guy's going to have a B. What's that third one going to have? Can't be A, can't be B, because we're already using them. Maybe it's C. Can we go back and look really quickly at the really long, complicated page of steps? Okay. In step number 2, it says factor the denominator completely until they're irreducible. We can't go any further. Is it okay to take x plus 1 squared and just put a number up top? Yeah. So even though there's a squared, we don't have to worry about the whole quadratic funniness? Yeah. We don't have to worry about the weird quadratic-y funniness unless there's an actual quadratic on the inside. But kiddos, don't we still have a linear piece on the inside? Okay, so we're good. Meaning, we can just put a C. A, B, C. A, B, C. E, F, G, H, I, J, K, L, M, N, O. X squared plus 1. You couldn't factor anymore. Nothing to do with quadratic. Alright. Now kiddos, between the whole multiplying both sides by the common denominator and the strategic values, which one did you like more?
I don't know. I don't like the truth to this.
Okay, Karina likes the strategic values. Let's go ahead and let's try the strategic values.
Okay, cool.
Question. We could say 4. What's one strategic? Now, wait, not thumb trick. Remember, thumb trick only works with non-repeated. But can't we still plug in 4x equals? Guys, why am I choosing 0? He's a 0 of that guy, right? And why am I choosing x equals -1? It's the 0 of the other guy. Now hold on, pause. Do I really want to plug these in as this messy thing is written right now? Ugh. Doesn't that look awful? So strategic values we are going to do, but what's the step that we forgot as to what we should have done before the strategic values? Okay, so even though strategic values is where we're going, we don't want to plug in right now. Do you guys really want to plug in there and there and there and there and there and there and there? No, we don't want to plug in. So instead, let's get rid of the denominator. Guys, for sake of time, when I multiply both sides by the entire denominator, which is this guy, right? When I multiply both sides by that guy, isn't the left side going to just be the top? And did you guys follow the pattern of the other one? What's the a going to get multiplied by?
X plus 1, X squared.
X plus 1 times x plus 1, right? Because what's going to happen when this gets multiplied to this guy? The x's will cancel, right? So we're doing a bit of a shortcut, not showing all the work. B is going to have an x, but who else is he going to have?
X plus
He's going to have 1x plus 1. And what's C going to have? Just an x. And once again, if you guys are like, wait a minute, what? Remember, this is what's going to happen when we multiply both sides times x plus 1 times x plus 1, right? This side cancels. We just have that guy left. And when we multiply this on the other side, remember, everybody has to have the entire common denominator multiplied. Him and him and him. And this is what we end up getting. Ew, gross. Oh well. We have our strategic values. Let's see if they work well now. It's a little bit easier to plug into. When x equals 0, you guys ready to plug in, Chuck? When x equals 0, wait a minute. Isn't that 0 plus 0 plus 6 on the left? 0, 0, and 6. On the right, I get a times, what's 0 plus 1? And then what's 0 plus 1? Plus b times 0. Oh, that's going to be nice. Plus c times, oh, ooh, I like this one, right? What's going to happen to these guys? They're gone. They're going to be zeros. So wait, do we already know that a equals 6?
Yes.
Yes. Go team. Okay, you guys already going to x equals -1? Oh, this isn't as nice. Positive 5, -1 squared is positive, minus 20 plus 6. What am I doing? Plugging in -1 here and simplifying. Equals a times, what's -1 plus 1? 0, right? How we doing? What am I doing? Plugging in. Yeah, I'm plugging in -1 to this whole guy, right? Okay. Now I have b times -1. Wait, what's -1 plus 1? Then I have c times, well, that's not bad. This guy's 0, that guy's 0. So what do I know?
If c is equal to -9, therefore c is equal to 9.
You guys see it? 5 minus 20, -15 plus 6 is -9. Equals -c, c equals 9. Oh, we like these strategic values. We got A, we got B, we're done. No, we're not. We see. Wait.
We got A, we got C, we got it.
Okay, well, how are we gonna find C? Do we have any more strategic values? No. So guess what? Oh, sorry, B. We're missing B. We're out of strategic values. Well, no, we're not. We're just out of the obvious ones. We can plug in any x values we want, right, Eric? Cool. So what's another nice small number besides 0 and -1? 0 and -1 we chose from the factors. But who else could we choose? Yeah, 1 sounds nice and easy, right? Are we allowed to do that? Sure. Does it come naturally from the problem? Not really, but oh well, I need to have another point to plug in. Now, what else do you think I'm going to plug in as I plug in 1? Plug in the A and plug in the C. But maybe we can just plug in the 1 first, right? So we will get 5 plus 20 plus 6 equals A. Wait, who is A? No, let's just plug it in. 1 plus 1 is 2. 1 plus 1 is 2 plus B. Who is B? I don't know. B times 1, B times 1 plus 1. Plus C. Who's he? 9 times 1. All we gotta do, guys, is simplify. And over here we end up with 31. Over here we end up with 24 and 9 and 2B. 31 minus 24 is 7. 7 minus 9 is negative 2. If negative 2 is equal to 2B, someone please be double checking my work. B is equal to negative 1? Negative 2, right? And then divided by 2, negative 1? What does that mean? Way back here at the very beginning, I've run out of room officially. This guy is equal to x plus, oh yeah, remember, wasn't there an x to begin with? X plus somebody over x plus 1, somebody over x plus 1, quantity squared. And A was 6, B was negative 1, C was 9. We put our partial fractions together with what we got the whole number from division, and we say, ha, we have rewritten and broken down U. Well, U, that functiony thing. Now, hold on. We have worked with non-repeated linear factors all the way down to the thumb trick. We like that. We have worked with improper fractions first and then the yucky repeated linear factors, but that worked also. What is the one thing that we have not worked with? Oh wait, you guys know all this. Don't worry, this is just saying strategic values. I don't think you guys need 2 paragraphs of strategic values, do you? What? No, good thing is we have like 30 seconds for me to show you the idea. For me to show you the idea. We might not actually grade this until Tuesday, but we're basically done. We'll do one example on Monday. What's the basic idea? Guys, when you factor, don't you get x squared plus 4? Wait, how do you factor x squared plus 4? You don't. If you set that equal to 0, guess what? He's imaginary. That cannot factor anymore. There are no real factors for him. So what does this change? Ready? You have an A, and according to our notes, wait. You cannot just write a B. We have to write a BX plus C. But guess what our next step would still be to do? Just maybe we have to use a system and we can't use many strategic values for this one. I don't know, strategic values could work too. Hi guys, work on 7-4 this weekend. We're basically done. But you might get stuck on the quadratic ones just a little bit.
Thank you.
Bye guys. You're done. Calculator, right?
Yeah. I'll get it out of the way. I'll get it out of the way, then I can spend tomorrow working on this section or chapter.
Okay, sounds good. Because then you can focus over the weekend and then,
Yeah.
that'll be good.
Hey, awesome.
Perfect. And put in the book, right?
Yes.
like it.